All right, so let's go with it. Let's go with the presentations first here. So presentations, you guys can do presentations. I can't do the schedule. I can't bring the schedule up either because the internet's not working. So, so projects. What are projects? Projects are something that interested you in anything we've covered so far in Algebra 2, or something that you connect to from real life to algebra, algebra to real life. We good? So it's just this sort of connection that you can make. You can go on internet. Let's see, in previous times, computer coding, that was one way some people connected. Architecture was another one people connected. Algebra and life. We good? And so if you guys can, I already have 2 submissions here. One person did the history of the naming of algebra already. So that's taken.
Wait, you have to claim things?
You do have to kind of sort of claim things.
Algebra and music.
Algebra and music. The free throw. Okay.
I claim infinities.
We were actually claiming.
So
I claim algebra and forensic science.
okay, that's fine too.
Algebra and music.
Just as long as I know at least something what you guys are doing. Okay.
Some history of the development of algebra.
This one.
Yeah.
Some way, somewhere. Okay, so these are just my thoughts. You don't have to. You don't have to pick one from these. This is just the suggestions. We're good.
But then we'd have to like think up our own things.
Well, it can be
like forensic science, right?
algebra
That's
and
one thing. So
blank,
you can,
or it could be more.
Yeah, and let me just tell you, it was really hard to find because everything in forensic science has to either do with physics or statistics. So I had to work a lot to find stuff with algebra.
algebra. Okay. Sorry about that. Okay, so we're good. Presentations. Presentations.
Next to positive. No, sorry. Both rational and no. Is it rational and irrational infinities?
Okay, we can do that.
I think that's the
Kind
one.
of, sort of.
Not
Okay.
rational, but like,
As long as you guys tell me, like yes, that'll be fine to do. Forensics will be fine to do. Free throw will be fine to do, right? As long as I kind of know what you guys are doing, right? Not like 7 people doing the same thing. That's what I don't want, right? Okay, so real quick here.
We all had our own unique takes.
Yes, so I've allowed people with the same thing because they were totally different, right, from each other. So that was cool. Like architecture was totally different, so I allowed both of them to do it. All right. I do have a rubric for you guys. This is the rubric if you want to follow it. It was given to you guys as well here. So this is...
we have the option to follow.
If you want to pass, you should follow it.
So rigor, it should be rigor. So you get a 1 if my 5-year-old can do this demonstration. You get a 1 for that. We good?
Whoa.
If the rigor is about middle school level, you get a 3, and then pretty much if you get it's like appropriate for high school, that gets you a 5. We good? Your peers are also going to grade you, and I'll pretty much take the average of your peers.
When is this?
So you could do this anytime. Just tell me the date that you want to do it. I'm going to limit you guys to 5 minutes, though. We good? Just so we don't do it all. Don't take a whole class period. We good? So there's 13 of us. That is already a full class period just by 5 minutes each. We're good. Alaka.
What do you mean by rigor exactly?
It's going to involve some algebra. I mean, it's going to be, you're going to show it to me, you can see the algebra presented. We good? I mean,
okay.
and that's what I just want to, like, if a 5-year-old can do it, that's not rigorous enough for me. We're good? But yeah, so it depends, I guess, how smart the 5-year-old is, but that's fine.
There are 5-year-olds smarter.
So, key concept was that presented, voice and delivery, the transitions. There's one, this is because one student had really bad transitions, but because they were all over the place, so I had to just, okay, you have to it has to be sequential, it has to make sense as you go through it. And then eye contact, you're not just reading off a script, you actually know what you're talking about, you've thought about it, you've rehearsed it a little bit here. Connections to what we've been doing. And then the slides themselves were a good way to present the material, and then you do cite your sources. We're good? So there's your category. It's 40 points total, but and I did send this to you guys, right? So you guys
Yes.
So there is the option.
There's not an any date. You just tell me. Preferably is you send it to me by Google Slides and say I'd like to do it on the 11th
11.
or the 18th, or 19th from now. It's a week from now, right?
19 is like the last.
We can go all the way to the 31st.
Oh, dang. Okay.
So I wouldn't mind actually taking it all the way to the day after because it's just going to be a grade in the class. I'm going to grade it and we're done, sort of thing. So it's not. You guys will grade your peers, and then I'll also grade as well. So I'll take a combination of those.
Guys, we just gotta like all give each other 100%. Can we agree on this?
I think everyone should just do no, that's not bad.
Okay, let's go with it. Next thing is the study guide for the final. We good? Good. Abby, we good?
Yeah.
We good. Study guide for the final. I sent this to you guys as well. Ready? So these are the questions that are going to come up. This one actually what the question is. This is where it's coming from. We good? So the first question on the test is going to come from 1.7 and you're going to have to do these things right here. The second question off the test is going to come from 2.5 and you're going to have to do these things. So you should be able to go back to your homework. You should be able to see, or you should at least know what the type of question will be. It's not going to be the same answers. I'm going to problem. Obviously, I'll change the numbers around. So like the question number 3 is going to say use synthetic division to find the quotient remainder. And it's going to come from 2.3. So 2.3 you should find somewhere in the homework where you have these instructions or something very, very similar. We good? So you do have a non-calculator section. You do have a calculator section. Right there. So this is, notice it's a little bit heavy on chapter 3 just because we don't have a chapter test on chapter 3. And then for the honors questions here, I'm going to throw in some application question or an extension honors question. Going to come from sort of anywhere, sort of thing. Yeah.
Oh, okay. So we have a presentation, a verbal exam, and a written exam.
Yeah.
Okay.
The test is next week, right? The written exam?
The written exam is is it Monday? Monday of the third week. So 2 weeks. Yeah. 1.5 weeks from now.
Great. That is actually
I
really
thought it was
helpful.
next week.
Okay. And then also we have a verbal final. So, and I can't get to the internet, so I don't know what the schedule is right now here. So verbal final is this right here, guys. I'm going to randomly select one of these problems, and you will have to do them in class on the board right over here. We good? So it's a homework problem. You've already done this before. It's just a matter of you explaining it. So if you, whatever formula you're going to use, you're going to write down the formula, and you're pretty much teaching the problem. We good? The whole point here is if you've covered these problems and you have memorized these problems, you have a very good understanding of what we've covered so far in class. We good? That's kind of summary questions. Go ahead.
So one's like the 3.4. Are we doing 3.4, 29, and 81, or are we just doing one or two?
One or the other, yeah. It's either going to be 29 pulled out or 81 pulled out. So I'm going to have a random number generator, literally, and I'm going to press it, and it's going to say this problem. And
It's just one problem.
See again?
It's just one problem.
One problem. Explain on the board, you're good. So for the honor students here, I added 3 more problems for you guys, 83, 115, and 75. So again, just have to explain it, and you're good to go. So the Canon students, I'm going to make it so that you can't get these problems. And for the honor students, you have the, it's not like you're going to get those problems. You might get those problems. You
The
have to
ones
study
in
those
brackets
too.
are the honors.
Uh-huh. Okay, we're good there. Does that make sense?
Are we allowed to use calculators on the verbal exam?
I don't think you need to calculate any one of them.
Oh, okay.
On the trig stuff, I know you had to calculate, but not this one. So all of them should be able to do. That's why I said the exact answer instead of rounded, and so I made them non-calculator. Okay, are we good there? Does that make sense? Okay, with that, with the time remaining here, let's jump to 3.1. We got to finish up the notes for 3.1. 3.2, we're actually not even going to get to 3.2 today. This one, let me find which one I want to do. Nope. Sorry, let me jump to this right here. Algebra 2. Okay, we left off last time. Is somewhere over here. You guys talk to me here. We did this right here, the one-to-one property. As long as the bases are the same, right? We can solve for the exponents and they will give us the correct answer. We started graphing these guys. And so we know that the graph kind of looks like this. It's flat on one side and kind of just steeps up on the other. We did that. And then, did we do this one as the calculator? I think we did that. We did 6, right? You guys take a look at your notes here, see if you guys agree.
We're just on to the natural base.
Yeah.
Awesome. Okay, we graphed this one here. We have a horizontal line. Do we do those? And then we have this one. Okay, we stop right here with 25. Okay, cool. Let me grab my notes real quick here. Okay, boom, boom. Cool. Continuing on, so Landon, you don't have these notes, right? But you have the video for it here, so we're just going to continue. So the natural base E, just like pi, we talked about pi being equal to this. That's the formula. When I used to teach this a way long time ago, I used to have students bring in all these different circular objects. So usually it was like the top of a soda bottle, right? Because those are small enough. Some person brought a metal, the old style metal garbage cans with lid, you know, the rounded ones. That was fun. So we measured the diameter across, right? We measured the circumference around, and we just put circumference divided by the diameter. It turned out to be 3.14 for that big old thing. And then also for the little soda cap bottles, it was still 3.14-ish, right? So it's the remain constant, that's pi. Pi is just the ratio of the circumference over diameter. All right, approximated by 3.14. E is very similar to it. E is an irrational number. It is approximately this right here. You have to get all the way to calculus to figure out the formula for it though. So we're not gonna cover the formula. You can kind of get away with something else. This is called a limit, but you have to sort of figure out what limits are. So I'm going to give it to you here. So E is approximately 2.71828. We good? Now we use that as we call a natural base. So when things grow, we almost use that as the base for growth because it fits a lot more in the natural world to have that number there. Okay, so what do? Let's jam. So use a calculator. We're going to evaluate these guys here. So if you have a calculator with you, let's go for it. Not going to do all of them because of the time restrictions here. So e to the x, just want you guys to be familiar with it. There's an E button on your calculator. So we want to be able just to do this right here. So A is e to the -2. Let me jump into my calculator as well. So where's the E button? Anybody?
Isn't it the second one of the division?
Cool. Okay, so real quick here, you got this little E right here, and that's the alphabet E for your calculator. We don't want that one.
On the left, on the line, is that it?
Hey, all right. So if you go down here along this line right here, notice you have an LN button, and then you have this little E to the X. That's what you want. So notice it matches up with the E to the X over here. So it's this guy right over here, and we'll figure out what the LN button is about on Friday here. But for E to the X, so in order to reach it, we have to put second and E to the X. And automatically opens up a little parenthesis because it always jumps the next thing into the exponent. Ooh. All right, -2. -2 in there. Boom, boom, click enter, and voila. Are we good there?
Oh, I'm crafted.
Mine didn't have the automatic parentheses, but if I added them, I got it.
I've also learned another way of doing that without having to do the automatic parentheses, where you can just press the X squared button and then go back and turn it into any number you want it to be.
Okay.
So if you put like 3 and then you press X squared, you can go back, like press the back arrow and change that number to whatever number you want.
Wow, that's too fun. Okay. That's awesome. Except we have to change the X one as well, but yeah, let's see that here. Everybody okay with this one? Did everybody get A? Thumbs up real quick here. Everybody with an A with the calculator? Boom. Okay. Let's go with D. All yours for D. So negative 0.3. Give me that one. And the answer is
0.74081822207.
awesome. Okay, so you include the 0. You can include the 0 if you like. You don't have to include the 0. That's fine too. We're good there. And then let's do e to the 1. Any guesses?
2.7182.
There it is. It's the number itself, obviously. Cool. All right, and technically if you square it, right? If you square this guy, so e to the 2 would be the same thing as squaring 2.718 times 2.718, which will give us about a 7.4-ish on that one there.
That's a very precise number, 7.4-ish.
Totally. Okay, so how do we graph these guys? Let's graph it by calculator. Mostly it's graphed by calculator here. So all yours there. Let's make a sketch. We know what it should look like, right? It should be flat on one side, right? And then kind of just zoom up on the other. That's kind of what we're looking for. And if you have that sort of whole space, then we did good. Let's sketch the graph of the natural function. Let's go and look something up. As you guys do that, let me look something up real quickly here. Okay, yeah, for these ones. Yeah, it's always using a graphing utility. Okay, so I'm going to go with clear y equals, jump over here, clear this one from we did earlier. 2, and then it's going to go e to the x, and how about a 0.24x as my variable. Close that off, and click enter, and I'm good to for graphing. Cool. Just a little bit here, boom. And click enter. So also this thing should go flat and then up, is that right? The reason why it should go flat and then up is because there's no negative outside and there's no negative on the inside of this guy. That looks like an exponential graph, is that right? From last time? Perfect. Okay, let's jump to the other one here. So if I see a half, I usually put a 0.5 in the calculator. Still the same thing. It doesn't kind of change anything for me here. E to the x, a negative 0.58x. Closing it off, enter, voila. And click on the graph. All right, and that one should go the other way. It has a negative in the exponent. And so this is, we call it a decay curve, which means something is going down. Down, down, down. And so the first one that we did, that was a growth curve. Population growth, whatever kind of growth you need. This one's the decay curve. Cool, all right. So let's jam. We got that taken care of here. So what do we use this for? When do we use this? We use this sometimes in something called compound interest. And so there's two formulas for compound interest. Let's do...
I hate compound interest.
Oh man, see, Albert Einstein said the exact opposite. Compound interest is should be the 8th wonder of the world. So.
The reason I hate it is because I know that I'm gonna get stuck in it at some point.
Oh, okay. So let's not do that. Let's go this way. I'm gonna skip quarterly. Normally, when the bank gives you interest, it is a monthly interest that you give if you put in a savings account. Also, compound interest works against you as well if you owe money. And there's also something called simple interest. But compound interest usually is for savings. So compound interest kind of works this way here. If you were to put in $100, and let's say you have 10% interest on your hands. So after, let's say a bank gives you 10% per year.
That is a
That's a good amount. Yeah, but just for purposes here. So notice after year one, you're gonna now have $110 in your account. Is that right?
Yeah.
So notice, and then next year they're gonna give you 10% of that money. So notice instead of getting an extra $10, now you get an extra $11 into your account, right? Because why? Because that extra $10 from the previous year
It's 10%.
is now your principal for the next year, right? And so compound interest tends to go up in value, and it tends to go like this. It tends to be flat for a while, and then it kind of jumps like that because of now the interest is sitting there that has gained interest upon itself. So that's kind of cool.
There
But
are multiple different types of interest, but they're almost never 10%. Unless you're loaning money.
just depends. Okay, so we're going to do B and C real quickly here. So monthly. So let's say this here. So let's say this guy's compounded monthly. Every single month we're going to get interest on $12,000, annual rate of 9%. And let's take a look at the balance after 5 years. We're going to have to do it on a calculator, but let's jam. So $12,000. It's 1 plus the rate, 0.09, because 9%. And N is the number of compoundings per year. So on a monthly basis, isn't 12 the number of compoundings in a single year? There's 12 months in a year? Yeah. So then for the exponent, it's going to be 12 times 5. Okay, can we punch that into the calculator? 1 plus 0.09 over 12, and that's going to be 60 for us right there. Let's see what. So let me jump to.
Where did that 12.5?
12 times 5.
Oh,
That's the N number of compoundings per year times 5. So this is all right. Neat, interesting story here. So when I started working, I worked at a telephone service, teleservices for Bank of America, and it was the late 1990s, and people were calling in like crazy. I, being just a college student, had no clue about finances. And so people were coming in, and the Bank of America was offering about, actually 10% if you had enough money. You can put in 50 grand. They were offering 10% on a CD. But the going rate was about 7 to 9% on a CD in 1998, 1999. And I did not know, like, why would people want to do that? Why would people want to lock in their money? And so it wasn't until the crash of 2000 that now the going rate for CDs is about 1% max. If you can find 1%, that's awesome. Could you imagine getting 10%, locking in money for about 20 years or so? 50 grand. That'd be a lot. Okay, so let's go with it with time remaining here. Let's go with this right here. Let me scoot this over.
My dad had the opportunity to buy Bitcoins when they were still at, well, how is this? There was a whole thing that he goes to for work. And one of the things that there was like a stand set up there, and it was literally just a plastic table and a guy selling Bitcoins. Turned out it was the owner of Bitcoin, and he was selling them for 25 cents a Bitcoin.
Oh, wow.
So he had the chance, if he had put in $100, literally billions of dollars. Not like.
Let me finish up now, just because we have to finish up here. You guys, okay, you guys are a little bit over 18 grand, is that right? On the calculator here?
Yeah.
Just want to punch in the same exact digits I have here. So 18,788 and 17 cents. That's what we got there. We good? Now we have something called the, so this is compounded monthly. Now when we talk about inflation, what we do is we talk about continuous, let me move this over, continuous compounding. So this guy, notice, hey, the little E shows up now, look at that. So continuous compounding is a different formula. That 2.71828, again, it's a natural rhythm of growth. And so whenever we're talking about continuous compounding, not going to be by much, but let's go for it here. Let's find the $12,000 invested, and if the bank were to give you $9% continuously compounded for 5 years, what would you get there? So let's punch that in, and I think at that point we'll be done. We didn't get to Chernobyl yet. We'll get to Chernobyl next time. Times e to the 0.09 times 5. So there's a little extra parenthesis I get there, just so I can keep everything inside the exponent here. So if I click on that, not too much difference there. So 18,819 and 75 cents. Are we good there? Cool. Okay, so as far as homework is concerned, let's see what we got. I think we should be able to pretty much do all of it now here, but let me just check just to make sure. All right, and so we'll start 3.2 on Friday. So, ding, 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 ding. Yeah, we're just going to get a science problem, but for the most part, you should be able to do the rest of the homework at this point. So come with homework questions, and we'll handle 3.2. And have a good day.
Monday, right? 3.1.
3.1 due on Monday.
Wednesday, we don't have school Monday.
Oh, yes, thank you so much. Wednesday of next week.
Thank you.
Absolutely. You guys have a great day.
You too.